We're on to Unit 2, which is all about functions and graphing. We're sort of starting out of order here with 2.3, which is functions and relations. A relation is any set of ordered pairs. It doesn't have to be in any certain order. It doesn't have restrictions like a function does, but an ordered pair is any set. A relation is any set of ordered pairs. The x values are called the domain, and the y values are called the range. If we wanted to write the domain, we would just write a set with all of those numbers in it, right? If we wanted to write the range, we would do the same thing. A set, I'm messing up my swirly braces here, with all of these numbers in it, separated by commas. A function is a special type of relation, okay? What's different about a function and a relation is that a function cannot have the same x values matching up with different y values. So in this case, is a function? It looks like I have 3 matched up with 1, and I also have 3 matched up with -4. That is not a function. On the second one, is that a function? -1, 2, 3, -4. It looks like all my x values are different, so that is a function. Even if the y values match up, that's okay. That's not a big deal for us. For it to be a function, we just can't have x values with different y values. The same x value with different y values. Another way you can tell if something's a function is if you're given a graph, you can do the vertical line test. So the vertical line test says if we draw a vertical line, we should never touch 2 points. In this one, if I draw a vertical line just about anywhere, I'm going to touch 2 points. You see that? Touched a point there, touched a point there. That is not a function. Right here. Touched a point there, touched a point there. I should be able to do it anywhere and not touch 2 points. This is not a function. Not a function. All right, how about the one on the right? Not touching 2 points, not touching 2 points. But how about right here? Bop, bop. See how I just touched those 2 points? That's not a function. All right, on this bottom example, not 2 points, not 2 points. Doesn't matter where you pick to draw those vertical lines, it is a function. If we have a relation with ordered pairs, we could tell if it's a function as well by checking to see if any x value matches up with different y values. So here, 1, does it match up with different y values? Nope, it only matches up with 2. 3, it only matches up with 2. 5, it only matches up with 4. So that is a function. As long as any one x value does not match up with 2 y values, it is a function. Another note that we can make is you can't have, in a function, if we just have the equation, you cannot have y to an even variable. It has to have a y and an x. It can't just have x's. And it can't have y inside an absolute value. So in this case, is this a function? It's not a function because it cannot have y to an even variable. So that is not a function. Is this a function? Look at this. That even variable goes with that y. That is not going to be a function. That's also rule 1 there. Not a function. Anytime you have y to an even power, y inside an absolute value, it's not a function. Anytime you have just an x and no y, it's not a function. This is called function notation. If you have something like y equals x minus 2, function notation is just saying y is the same thing as a function of x. Y is a function of x. So we're replacing the y with f of x. You see that? This is function notation. Using function notation, if this is f of x, if I wanted to find f of 4, that's not the same thing as f times 4. That's f where x is 4, right? So that's the same thing as 4 minus 2 equals 2. Same thing here, f of 1. The 1 is replacing the x, so that's the same thing as 1 minus 2, which is -1. Here we've got an example. G of x equals 2x plus 1. If we want to find g of negative 2, that's g of x. Negative 2 is x. All we have to do is replace our x with negative 2. The same thing with g of negative 1. We just have to replace our x with negative 1. G of 0, replace our x with 0. G of 1, replace our x with 1. G of 2, replace our x with 2. These can look a little different. If I want f of a here, that means, again, this is just x, f of x, with function notation. I'm just going to replace the x with an a, right? So that'd be 3. It helps if you put it in parentheses when you put it in. You're going to do it everywhere there's an x, and then we're going to simplify. 3a squared plus 2a. This is going to be important in just a minute. All right, here, 3x squared plus 2x. But instead of x, I have x plus h. And now to simplify that, I would have 3x plus h, x plus h. X plus h squared is the same thing as writing it twice. And let's try and simplify even further. If I FOIL that, x squared plus 2xh plus h squared plus 2x plus 2h. That's 3x squared plus 6xh plus 3h squared plus 2x plus 2h. And look around and notice that there's no like terms. And so we're actually done right there. That was a lot of work, but anytime you have f of something, you're just subbing that in anywhere you have an x. All right, to find the x-intercept of a function or to find the y-intercept of a function, all you're going to do is sub in a 0 for the opposite thing. So to find the x-intercept, for example, you're going to sub in a 0 for y. You're going to say, for example, y equals 0. To find the y-intercept of a function, you're going to sub in x equals 0. So here, find the x and y-intercepts of this function. This is the same thing as y equals x squared minus 4, right? To find the x-intercept, I'm going to sub a 0 in for y. And to find the y-intercept, I'm going to sub a 0 in for x. Trying to solve both. This one, x is 0, y is negative 4. This one, y is 0, and x is... Look, when we solve this, square root both sides, we get positive or negative 2. We get positive 2 or negative 2. We get 2 x-intercepts. For any function, to find the x-intercept, you sub a 0 in for y, and to find the y-intercept, you sub a 0 in for x. For the y-intercept, your x-coordinate is going to be 0. To find an x-intercept, your y-coordinate is going to be 0. Y equals 0, right? X equals 0. That's always true. To find the domain or range of a function, remember back on that first slide, to find the domain, you're looking for all the x values. So in this one, the domain is negative 3, negative 1, 0. I'm looking at the x values here. 2, 4. And to find the range, I'm looking at the y values. So the range is negative 4. This should be, I put a parentheses, but that should be one of those swirly braces there. It's a set of numbers. Negative 4, positive 1, positive 3, and positive 4. And it's okay that they don't have the same amount. It's perfectly fine. Is this a function? That's a question. Does it pass the vertical line test? Yes, 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 it does. All right, the domain on this one, the second one, B. How far left does it go and how far right does it go? Domain is always left to right. It's on the x-axis. It goes everywhere from 3 all the way to infinity. Does it include the 3? The answer is no, because it's an open circle. So it goes from 3 to infinity, not including the 3. The range, we're looking from bottom to top. So it goes from here really all the way up, right? So it goes everywhere from negative 2 to infinity. Again, I put a parentheses there because the negative 2 is not included. We know that because of that open circle. The domain on the left, option C here, it looks like it's going to keep on going left, right, and it's going to keep on going right. Slowly, but it's keeping on going. So it's going to go forever this way and forever this way. It's going all the way from negative infinity to infinity. You would think the range would be the same, but on this one it's not. The range goes down as far as you want it to, but it does stop when we're going up. It stops right there at 4. The question is, does it ever get to 4? And it looks like in this case, we could draw a line, and it does actually get to that 4, right? There's a point there. So we'll have a square brace. Domain's always left to right, range is always bottom to top. If we're given an equation instead of a graph and we want to find the domain, there's really only 2 rules that we're going to follow, okay? And those 2 rules are, number 1, don't make the bottom 0. That's the denominator. Can't make it 0. And number 2, if we're talking about, we're going to end up graphing these things. These are functions, right? We can't square root a negative number. Anything that makes a negative in a square root is a no-no for the domain, because it's going to give us not a real number. It's going to give us an imaginary number. All right, looking at option A here, remember there's only 2 rules that we have to follow. There's no square roots here. There's no square roots, so we don't even have to worry about rule 2. Rule 1, we can't make the bottom 0, so what would make the bottom 0 here? If you can't just think of it, what we could do is say 2x minus 5 equals 0. Let's just see what makes it 0. So 2x equals 5, x equals 5 over 2. X can be anything except for that, right? That's the number that would make the bottom 0. X can be anything except for that. So if we look at that on a number line, 5 over 2, that's like 2.5, so 3 is above it, 2 is below it. X cannot be that. That should not be included. But it can be anything to the left of it. That's fine. It can be anything to the right of it. That's fine. And our domain is everything from negative infinity to that number, 5 over 2, and then everything from 5 over 2 to infinity. It can't be that number because that number makes the bottom 0, and you can't divide by 0. I'm going to erase to make myself some space here. On the next one, you're again looking for what would make the bottom 0. There's no square root, so we're not worried about the second rule again. But what would make the bottom 0? Is there any number that would make the bottom 0? X squared plus 4 equals 0. Subtract the 4. X squared equals negative 4. You could square root both sides. X equals plus or minus 2i. Try and put 2i on a number line. Can't do it. So if there's no restrictions, there's nothing that can make the bottom 0. There's no real number, I should say. There's no real number that can make the bottom 0. Then the domain is just negative infinity to infinity. By default, this is your domain, okay? By default, this is your domain. You're only going to take things out based on what the restrictions are. By default, your domain is negative infinity to infinity. Any regular line is going to be negative infinity to infinity. Most functions, cubic functions, any odd function is going to be negative infinity to infinity. The only time that it's not is when you have a restriction, okay? Looking at the third one, there's no way to make the bottom 0, right? So we're not worried about this rule, not worried about that rule. We are worried about making that a negative, and to find out what makes it negative, we can find out what makes it 0. So here, 2 minus 2 would be 0, right? And so let's put 2 on a number line. 2 is really our key point here. You can see a trend that you're always looking at what makes things 0, right? So here, 2 minus 2 is 0. We're going to put that on a number line. Can we include 2? If I put 2 in, can I take the square root of 2 minus 2? Can I take the square root of 0? Yeah, that's 0. You can type it in the calculator. You get a number, right? So we can include the 2. You can just check some numbers around it. And if I put 3 in, if I do the square root of 3 minus 2, in the calculator I get 1. That's fine. If I check any number on the left, if I put a 1, square root of 1 minus 2, in your calculator you get exactly what you expected. Domain, error. and that means this is not included, right? We cannot include that number. So our domain is everything from 2 to infinity, including the 2. Again, this is our domain. It's not a solution, it's just the domain. For these, we want to use the function in the picture. So we have a graph here. You see that? We can zoom in on the graph as we need to answer the questions. If it ever asks us what's f of 2, that means 2 is x, right? Remember, our function notation is f of x. What's f of 2? That means 2 is x. Where's 2 is x? Here's our x-axis. Here's 2. Let's go and find what happens to y when 2 is x. Y is 5. Do you see that? How about f of negative 5? Again, that's f of x. Where's x negative 5? It's right here. And if we go down, it hits that open circle, and that's a problem. We think it's negative 3, but it's really not. There's actually not a point there at all. You see that? There's not a point there at all. It's just an open circle. So that's no solution. Find all x for which f of x equals 0. Remember, f of x is the same thing as y. So find where y is equal to 0 this time. Here's our y-axis. Boom, boom. There's where y is equal to 0. Can we find all the places where y equals 0? That's at 4, and that's at negative 4. That's at 4 and negative 4. Find all x for which y equals 3. Remember, f of x is the same thing as y. Where's y equal to 3? 1, 2, 3. Oh, wow, that's an interesting one. It's 3 all the way from here to here. I need to erase to see my number line down here better. So it's 3 all the way from there to there, which is all the way from there to there, all the way from negative 3 to 1. That interval, right? That is an interval. It's not an ordered pair. It's an interval saying everything from negative 3 to 1. Determine the x-intercepts. Remember, the x-intercepts are where y equals 0. Didn't we already do that? We did. These are the x-intercepts. The x-intercepts are where y is equal to 0, and graphically, the x-intercepts are just where is it touching that x-axis. And in negative 4 and 4, it's touching the x-axis. Determine the y-intercept. So that's where x is 0. Where's x 0? Right here. And if we follow that up, y is 3. I should go back a step here. We really didn't write the y-intercepts correctly. They are points. An x-intercept is a point, just like a y-intercept is a point. So here, those x-intercepts, if y is 0 and x is 4 and negative 4, that would be 4, 0, negative 4, 0. Those are your two x-intercepts. They are points. Determine the domain of f. That's everywhere from here over, right? That's everywhere from negative 5 to infinity. And since we have an open circle, we're not including the 5. And determine the range. Again, we're going bottom to top. So how far down will it go? It seems like it'll keep going down here, huh? And how far up will it go? It'll go all the way up to 5, and it does actually touch a point at 5. So it goes everywhere from negative infinity up to 5, including the 5. And that's the basics of functions. We are going to keep on learning about functions this unit, different types of functions, domain range, increasing, decreasing, and all sorts of attributes of functions.